Okay, so we're going to look at measures of what we would call measures of average and of variability. So we have three different measures of average. So averages, I suppose, are always something that people have some concept of, and there's one of these types is probably the one that you would be the most familiar with. But we have actually got three that we're going to consider, and then one type of variability that we're going to consider here as well. But it's important to kind of be able to work with all of these. And these are what we call summary statistics. Okay, so a statistic is a piece of information about the data, and a summary statistic is a value that we can use to describe the data. So we look at averages, of which we have three, as I've said, and we're also going to look at the range, which is a measure of the variability. So how varied is our data? So our three averages that we're going to look at are the mode, the median, and the mean. Okay, so it's important, I suppose, to have that concept, that understanding of all three, and we're going to look even at maybe in what situations would one be more useful than the other. So the mode is the first one we're going to look at, and the mode, we remember MO for mode and MO for most often. Okay, so the mode is the one that appears in the data the most. It's quite clean cut, it's just the one that's there the most. We sometimes call it the modal value. Okay, that's really all there is to mode, to be quite honest. You pick out the one that's there the most, it is what it is. The median then is another type of average we could use. The median is the middle value when the data is arranged in order, an ascending order. Okay, so when you put your data in order from smallest to biggest, the median will be the one that's in the middle. Okay, so it's important really to make sure that your data is arranged in order, or else you're not calculating the median correctly. We can use a little trick in some situations to help us find the middle value. So I'm just going to put a note beside this here as well. That is going to give me the position, not the value itself. Okay, so what I mean by that is that this little trick helps us to calculate what the middle number of a set of numbers is. So if I have 10 points in my data set, then this would help me to calculate the middle number, the middle position for that data set, and I could then work to actually calculate the median itself. This can be useful if you have a large number of data points. If you have a smaller number, you might be able to just kind of eyeball and visually see which one is the middle. When we're looking with data sets, if we have an even number, no, sorry, excuse me, if we have an odd number of data sets, then there is going to be a clearly defined middle value. If we have an even number of data points, then our middle value is actually going to fall between two of the given values. So if, for example, I have 10 points in my data set, the middle value would be between the fifth and the sixth value. Okay, so we're going to look at calculating all of these in one large example here, but important to just kind of remember that idea. So the way that I would use this little trick that I pointed out here is, let's say for example we had 10 data points, then I would do 10 plus 1 over 2, which of course is 11 over 2, which is 5.5. What that would tell me is I need to look between the fifth and the sixth. If I had instead 7 data points, then I would do 7 plus 1 over 2, which is 8 over 2, which is just 4. So I would be looking at the fourth data point, and that would be the middle one. So you can see what I'm saying. If we have an odd number, we'll have a clearly defined middle value. If we have an even number, we're going to have to look between two of the values we've been given. The last average that we have to look at is called the mean. And the mean is, or the way I would remember it, is this is what people tend to mean when they say average. So when people say I'm looking for the average value, or what you might have, like what people might have learned in primary school or learned earlier, generally that's the mean is what you would have been calculating. It's kind of the traditional average value. So we add up everything we have, we count how many numbers there are, how many things there are, and we divide by how many there are. So add them all up and divide by how many are there. Okay, so that kind of standard average that we've been mostly used to. So the mean is the one people tend to mean, the median is the middle when they're arranged in order, and the mode is the one that's there the most. Okay, so let's get into looking maybe at an example or two. Um, yeah, we'll look at this example of calculating the mean and the median and mode. We'll start with the averages and then we can come back and look at some of the other information we need there. So the first thing I want to do is calculate my different averages. Okay, so we're asked to calculate the mode first. So the mode is the one that is there the most. So that is the most often one. So MO for mode, MO for most often. So what one is there the most? Well, I look at my data set and I can kind of clearly see that the one that is there more than the others is 20. So using the mode as my measure of average, I would say 20 is kind of an average value there. Let's calculate the median next. So to calculate the median, I need to get the middle value out of this data set here. So I have 10 data points. I add 1 and divide by 2. So that is 11 over 2, which we've said is 5.5. So I need to look between the 5th and the 6th value in my data set here. So let's look. The 5th value is 18. The 6th value is 20. So I'm looking for a value that is between those two. So what we'll do is add them together and divide by 2. And in this case, we're going to get a nice clean answer of 19. Now 19 is not one of the values that was in my data set, but that is okay. Okay, a data set, the average value of a data set doesn't have to be a value that was actually achieved in that data set. So there's an average of around about 19 for this data set here. Let's look at calculating the mean next. So to calculate the mean, I add them all together. So 6 plus 12 plus 15 plus 15 plus 18 plus 20 plus 20 plus 20 plus 22 plus 25. So let me see, can I get my calculator up at all here? So 6 plus 12 plus 15 plus 15 plus 18 plus 20 plus 20 plus 20 plus 22 plus 25 is 173. We're going to divide that by how many data points we had, which was 10, and we get an average of about 17.3. So we can see there we've 3 different types of average, and each of them has presented me with a different result, slightly different. The mode and the median are fairly close together there, and the mean is slightly below both of them there, a little further than they are from each other. So each of them presenting a slightly different version of what the average is here. So hopefully we're following the method in how we're calculating each of those averages, and we'll have a look then at how would we distinguish or whether one is better for this data set than the others. So the next thing to consider would be variability. Okay, so that would be looking at the range. So that's the next thing I want to look at. So the range looks at the variability of the data as opposed to the average value of the data. So the range of a data set is the difference between the highest and the lowest value. It's just a measure of how spread out is our data. Okay, I've put a note here to say that the range is very useful in describing the data because it tells us kind of how spread out everything is, but because it only uses 2 data points, it can be influenced by outliers, and an outlier is a value that stands out from the rest of the values, so it doesn't fit in with the typical values of the data set. And because those values by definition would often be the highest or lowest values, then the range can be very affected by those values, so it can make us think that our data is much more spread out than it is. So if we applied that to this data set that we have, the range would be the highest value, which is 25, minus the lowest value, which here is 6. So I would get a range there of 19. If we ignore the outlier of 6, then my range would be 25 minus 12, which is 13. Only a small bit smaller of a range, but still a significant enough margin. Okay, it's nearly a third smaller than it was. Okay, so you've kind of lost 6 there in your actual range value. So bear that in mind. An outlier can really have a big impact on the range of your data. It can make you seem like the data is much more spread out than it actually is. But calculating the range is probably much more straightforward nearly than any of the averages. We take the highest to the lowest, we subtract the 2, and it tells us how spread out everything is. So to answer this last part, we have one more extra little bit to look at, and it's to do with our averages, and we'll tie our range into this as well. But when looking at our averages, there's reasons why one might be better suited to our data set than another. And it really comes back largely to our outliers. So our outliers can play a big role in our calculation of our averages. They can influence, like we saw for the range, they can really influence the value that we get, and they influence some of our calculations for average more than others. So if we go through the different averages, the mode can be useful because it's easy to find. It's easily calculated. You just look and see what's there. It's useful for categorical data. So if we have data where we don't even have numbers, we just have actual words or categories, the mode then is obviously going to be the best to use because we can't even really calculate the other ones. And the mode is typically not influenced by outliers really. The disadvantages there that there may not be a mode, so there mightn't be one data point that is more prominent or more popular than the others, and there's not much else that we can use the mode for. It just tells us which one is there the most, and like that's all well and good, but we can't do a whole pile with it. The median can actually be quite useful because it can be easy to calculate if the data is ordered, and it often isn't hard to order the data either. And the median is not influenced by outliers because we're looking for the middle value. We're not looking at those extremes of highs and lows, so we're not including the outliers typically in our calculations. The disadvantages there, as we saw, is it may not be a value in the data set. That can be a slight disadvantage if we're looking to compare what people got within an exam. It can be annoying if that median value isn't a value that's there. And again, there's maybe not a whole lot of further analysis that we can do here, but it can be useful for data sets where there's potential for outliers. It gives us that kind of middle value. It gives us a sense of like, within this spread of this data, what could I consider to be a middle? Okay, and really that's always what we're looking for with an average. Like, what's a good kind of middle ground value here that would summarize all of this data? And the median does that quite well typically. The mean then, as we've said, is the one that people can tend to be most familiar with. It's easy to calculate. It uses all the data, which is good, okay, more than the others. So the others really at most use maybe 1 or 2 points. This uses all of them, and there is definitely further analysis we can do with the mean. However, the mean is again influenced by outliers. Because you're using all the data points, you're going to be including those outliers, and they can have a real effect on the data. And again, the mean, like the median, is not always a value that's in the data set. So let's apply that to this part 3 of this example. Which of the averages is most appropriate for this data set? So looking at the set here, we have a lot of numbers that are very close together, but we do have that 6 that we already identified. And that 6 to me is a bit of an outlier. It kind of stands out from the rest of the data. It's a fair bit lower than any of the other ones are. Okay, even the 12 is slightly lower again than a lot of the other ones are, but the 6 to me really stands out there. And I think for that reason, you would want to choose a measure of average that is not as influenced by outliers. So I would probably say there that the median is probably my best measure of average because it's not influenced by the outlier. And it gives us a nicer kind of measure of kind of the middle or average value for that data set. We could use the 20, but kind of visually the 19 does feel like it summarizes or describes that data a bit better. And again, all of this is really just about you choosing one and giving a reason or a rationale for it. Typically, the mean or the median might be better averages to give than the mode would be. But yeah, important to just kind of recognize the different kind of advantages and disadvantages of each of those. Let me see, we've loads of questions here. We'll not do them all, but we'll choose 1 or 2 that we can have a look at. So let's look at this one here, 2020 sample paper. Write 3 integers into the following boxes so that the 3 numbers have a mode of 2 and a mean of 5. Well, a mode of 2 means we have to have 2 being the most common number there. I can at most have 2 2's because if I have 3 2's, I will not have a mean of 5. Let's dwell on this one for a little moment. If I want to have a mean of 5, let's think about what that would mean has happened here. To have a mean of 5 means that adding these 3 numbers together has an answer of 5. So let's say, for example, that we'll call this one x for the moment because we don't know what it is. The idea here is that these two numbers plus x are divided by 3 and the answer is 5. Like that's essentially the sum that we've been doing here. So another way of thinking about this is the three numbers must add to 15. The 15 being the mean of 5 times 3. So the three numbers that I have here must sum to 15 to give me that mean of 3. And we already know two of them have to be 2 because we need a mode of 2. So since we've already included 2 and 2, which is 4, the last one must be 11. Okay, let's look at part B. Similar again, this time we've 5 integers. We want 5 numbers that have a mode of 4, a median of 4, a mean of 5, and a range of 12. Okay, we've a lot of information to look at here. I'm actually going to start with the second one, which is the median of 4. So remember what the median means. When they're arranged in order, the median is the middle value. Now 5 numbers has a clear middle value. If I have only 5 boxes to fill in, this is clearly the middle one. And if the median has to be 4, well then that value has to be 4. So that's us kind of finished there. We need a mode of 4 also, a mean of 5, and a range of 12. Okay, I'm expecting, because there's kind of a few different elements or layers to this, that we'll actually be given a fairly wide range of numbers here that we would be able to choose from. So let's look at kind of what we're seeing here. If I want a mode of 4, I know I need at least one more 4. Okay, I could decide to kind of put that wherever I choose, really. We need a mean of 5, so let's look at the mean of 5 as well. Mean of 5, but there are 5 numbers, so the mean of 5 means we need a total of 25, and we also need a range of 12, which means the difference between these two needs to be 12. They need to be 12 apart from each other. Okay, so let's pick a few numbers that we could try and work with here that are going to add up to 25. Let's say that this might be 13 and 1, for example. That would give us a range of 12 there. Where does that leave us for the moment? We need another 4 as well. So let's see, does that actually work for us? 1 plus 4 plus 4 plus 13. That's going to give me 1 plus 4 plus 4. That's 9, 22. I need a total of 25, which means I'm missing a 3. So we have to do a little wiggle work here. If the middle value is 4, that has to be the middle when they're in order. So I might replace my 4 here and add my 3 in here. And in that way, I now have 5 numbers that add together to give me 25, which when divided by 5 gives me my mean of 5 I wanted. I have a range of 21. The biggest take away the smallest is 12, excuse me. The median of 4, the middle value is 4, and the mode is 4. 4 is there the most. Okay, that's an example of a question where it's actually quite open-ended. There were a few different values you could have filled in there to satisfy that question. And it's all about kind of how you interpret the conditions that have been placed there. So let me see, we have a few extra questions here that we could look at. I'm going to look at this one next then. John measures the heights of 8 students in his class. Their heights in centimetres are given as follows. Work out the range of the data. So to work out the range, the data must be in order, and we can see here that it is. So the range is the biggest, take away the smallest, 141. So that is 31 centimetres. We're asked which one of the heights is an outlier. Here I would say that the outlier is the 141. It is much smaller than the others. And we can put a little note maybe that it is 24 centimeters from next height. When you're looking for outliers, you are typically going to be looking at the tallest or the biggest or the smallest number in your data set there. Work out the mean of the data. So to work out the mean, we'll add them all together. 165, 167, 168, 169, 170, 172, 172. So let's get our calculator here. 141 plus 165 plus 167 plus 168. I've missed one there. 167, 168, 169, 170, 172, 172. Solve. So we've 1324. And we're going to divide that by how many data points we have. They said it's 8 students, so there's 8 data points there. And let's see what that gives us. 1324 divided by 8 is 165.5 centimeters. So 165.5 centimeters there. Again, not one of the data points we have, and actually quite a low data point there, which is nearly making me think, did I miss one of my data points in my sum there? But I don't think I did. So quite a low data point there, which we'll maybe just put down to or attribute to that outlier being so far below that it's actually pulling that mean value downwards by being included there. Maybe just to finish out this one, it doesn't ask us for it. It doesn't ask us for it, but let's just do a calculation of the median as well, just to practice. So the median is the middle value. So for 8 points, the middle is 8 plus 1 divided by 2, which is 9 divided by 2, which is 4.5. So we're looking between the 4th and the 5th value. So let's look here. So the 4th value and the 5th value. So between 168 and 169. And divide by 2, that's going to be 168.5. So we can see how not having that outlier there has allowed our average value from the median to be a little higher. The last part then, John also measured the heights of the teachers in the school, and he said most of the teachers in my school have a height that is greater than 175. Put a tick in the correct box to show which of the following statements must be true based on what John says. Tick one box only and give a reason for your answer. So he says most of the teachers have a height that is greater than 175. So that could mean that the mean height of the teachers is greater than 175, that the median height of the teachers is greater than 175, or that the modal height of the teachers is greater than 175. Well, the median value is defined as the middle value, so it should be the value that is directly halfway into the data. So if the median is greater than 175, then that would mean that more than half of the data would be below that 175 mark. So it's unlikely to be the median. The modal value doesn't really impact that most of them are greater than. So there I would be leaning more towards the idea that the mean height must be greater than 175, because if more of the teachers are greater than 175, then that should have a result of dragging the mean height upwards and kind of leaving you with more of a kind of general middle value there. So I would go with the mean height in that case. So basic summary here, your 3 calculations of average. Mode is the most often, median is the middle when they're in order, mean is kind of your traditional average, add them all up, divide by how many there are. There are different advantages and disadvantages for each of them, and the range then is a measure of the variability. It tells us how spread out the data is, and it's just the largest data point minus the smallest data point.